Good morning. Discussion topic: design the fraud detecting model that classifies the transaction as fraudulent or non-fraudulent. Myself Abhishek, my team members Jitendra Patil, Karthik Karan, Ravi Kumar V. Content: introduction, methodology, implementation, conclusion. Introduction: as a digital transaction increasing the so does the risky of fraud, which is the cyber crime. Using the advanced methods to avoid the detecting traditional rule-based system. Often the fail identify the new fraud pattern. This is the assignment exploring the fraud technically. Isolation forest and local outlier factor. This model detecting the unusually transaction behavior without requiring the label data, making them effective adapting to evaluating the fraud detectors. Methodology approach. Data used source Kaggle. Detail detail 2,84,807 transaction, 498 fraud cases, PCA transforming future time amount class, pre-processing step, remove, removed time column, scaled amount using the standard scaler, split data set into training and or testing. Algorithm applied, isolation forest, local outlier factor, logistic regression, flowchart of the processing, load dataset, preparing the data, apply the anomaly detecting, evaluate result, visualizing finding. Next will be continue with the Karthik RN.
Good morning, everyone. Flowchart analysis. The flowchart illustrates the complete pipeline of fraud detection. Begins with the training and testing datasets. Event logs are filtered and analyzed through four lenses. First one is control flow, second one is resource, third one is throughput time, and fourth one is decision point. These analysis helps identify potentially fraudulent behavior. Association rules are generated and checked for compliance with legal and fraud rules. The final fraudulent status is confirmed through expert verification and rule-based checks. Check. Next one is dataset and evaluation metrics. A sample of transaction dataset is shown with features of time V1, V2, amount and class, fraud or non-fraud. Evaluation metrics use precision, recall, F1 score. In precision, measures accuracy of position predictions. In recall, measures how well actual fraud cases are identified. In F1 score, harmonic mean of precision and recall, balancing both. Third one is model performance. 3 models were evaluated in this. First one is isolation forest, second one is local outlier factor, third one is logistic regression. In isolation forest, high F1 score, balanced precision and recall. Second one is local outlier factor, good recall, slightly lower precision. Third one is logistic regression, highest precision but lower recall, resulting in lower F1 score. In visual outputs, confusion matrix is included, precision recall curve is included, anomaly score distribution is included. Next one is explained by Ravi Kumar.
Good morning, sir. Good morning, sir. Good morning, everyone. Myself, Ravi Kumar. 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 Good morning, everyone. Myself. Good morning, sir. Good morning, everyone. Myself, Ravi Kumar. This diagram shows confusion matrix. Confusion shows how well the model classified fraud versus non-fraud. 56,854 normal transactions were correctly identified true negative. 92 frauds were correctly detected true positive. Only 30 normal transactions were wrongly flagged as fraud, false positives. These two fraud were missed false negative. Second one, precision. Measure how many predicted frauds were actual fraud. High precision means fewer false alarms. Recall. Measure severe fraud were catch. Precision recall curve means the histogram top class score distribution, x-axis score. This represents the model of confidence that transaction is fraudulent, closer to one equals more likely fraud. Y-axis density, this shows the number of transactions at each score level. Red bars. Red bars are represents normal transactions, not fraud. Blue bars. Bars are represent fraudulent transaction. Observation: most normal transactions have lower fraud score 0.02 to 0.04. It should be continued by Jitendra R. Patel.
Good morning, everyone. I am Jitendra. Today I am going to explain the Python code. In import pandas.pd, it refers to the for data manipulation and analysis. It is used for rewriting data and handle tabular data using data frames and perform operations like filtering and grouping merging. Next, coming to the import numpy as an ESNP provides support for large multi-dimensional arrays and mathematical operations. Common uses is faster computations, linear algebra, and random number generation. Next, sklearn.model and selection and train test to split splits data into training and test sets and ensures the class distribution is preserved in both sets such as fraud and non-fraud. Next, coming to the sklearn.preprocessing.standard scalar standardizes features by removing the mean and scaling to unit variance. Next, from sklearn.assemble import isolation forest and unsupervised learning anomaly detection algorithm isolates anomalies by randomly splitting data points in trees, and anomalies are isolated faster. Next, sklearn dot neighbors dot local outlier factor, another supervised anomaly detection method, detects points that have significantly lower density than their neighbors. Next, sklearn dot learn model, linear model, logistic regression, and supervised classification algorithm used when the output is binary. uses sigmoid function to predict the probability of the positive classes. SQL dot matrices provides functions to evaluate model performance and precision out of predicted frauds. How many were correct and out of actual predicted, how many were caught. F1 score is the harmonic mean of precision and recall. Next, coming to the data frames is equals to uh, data frames is equals to pd dot read csv. Next, content final tuned fraud data sets are dot csv, and loads a csv file containing transaction data. Next, coming df is equals to pd dot read csv, which is used for reading the csv file. And next, coming to the x is equals to df dot drop loads a csv file containing transaction data. X features all columns except class. Next, y is equals to data frame class labels target variable, typically 0 for normal and 1 for fraud. Next, scalar is equals to standard scalar, which is a function. X dot underscore scaled is equals to scalar dot fit transform x. Standardizes the features, so they have a mean of 0 and standard deviation of 1. This is important for algorithms sensitive to feature scales. Next is x underscore train, comma x underscore test, y underscore train, comma y underscore test is equals to train test is split. Next, x underscore scaled y, comma test size is equals to zero point 0.3, comma stratify is equals to y, and random state is equals to 42. Splits the data set into 70% training and 30% testing. Uses stratified sampling to maintain the same fraud to normal ratio in both the sets. Next, ISO is equals to isolation forest contamination is equals to 0.1, and random state is equals to 42. Y prediction if is equals to ISO dot fit dot predict X test. Next, Y underscore predict if is equals to bracket 1 if P equal to -1, else 0 for P in Y prediction underscore if detect anomalies by isolating outliers. Contamination is equals to 0.1, tells the model 10% of the data are expected to be anomalies, and converts the prediction -1 anomaly to fraud and 1 normal to 0. Next, LFO is equals to local outlier factor, and local outlier factor n underscore neighbors is equals to 20, contamination is equals to 0.1, and y prediction LOF is equals to LOF dot fit dot underscore prediction x test, and y underscore prediction underscore LOF is equals to 1 if p equal to -1, else 0 for p in y underscore prediction dot LOF. Identifies anomalies by measuring local density deviation. Also converts prediction -1 bar -1 bar 1 -1 to 1 and 1 to 0. Next, coming to the LR is equals to logistic regression. Max iteration is equals to 1000. LR dot fit x underscore train, comma y underscore train, y underscore prediction underscore LR is equals to LR dot predict X test, a supervised learning model that uses actual training labels to learn, predicts whether each transaction is X test is fraudulent or not. DF define is used to define a function, evaluate y underscore true and y underscore prediction, comma name, colon, p is equals to precision score, and y is equals to y underscore true and y underscore prediction, zero deviation is equals to zero, r is equals to recall score, y underscore true, and y underscore prediction, zero underscore division is equals to 0, f1 is equals to f1 score, y underscore 2, y prediction, and 0 deviation is equals to 0. And next printf, which is used for printing the precision, recall, and f1 score. Precision means how many predicted frauds were actually fraud, and recall means how many actual frauds were correctly identified. F1 score is the harmonic mean of precision and recall. Next, the print statement model performance evaluate y underscore test and y underscore prediction, if which is used for printing the isolation forest. And next, two is used for printing the local outlier factor and logistic regression. This is all about our presentation. Thank you. And next, coming to the output, these are the isolation forest precision is given as 0.56, recall 0.56, and F1 score 0.556. Precision of local outlier factor is 0.67. Recall is also 0.67. F1 score is 0.667. And next, logistic regression is precision dot 88. Recall is 0.78. F1 score is 0.824. Thank you.